Good morning, and once again, yours truly, Dolphy Gilpin, coming to you from the Hilton at 5711 West Century Boulevard, Los Angeles, California. And then continuing with application to our Amz5x12 matrix. This morning, I'd just like to do a little sort of unplanned, impromptu sort of build up here on the matrix application. And for this, we're going to be using arbitrarily now some parameters for the elements of the matrix components. Later on, we'll come to show you exactly what we're doing, but for now, for the elements, we are going to use some differential operators. For example, for A11, for the first element in row 1 and column 1, we'll have dx, d by dx, 1, 1, d by dx, 1, 2, d by x, 2, 1, and d by dx, 2, 2. And this is for 2 cross 2 components derived from now the Amz5x12 matrix. And suppose now we have now that we're using now simply representation here for this first row, first column, d by dx, 1, 1. Suppose now that we have d by dx, 1, 1 now, says equal now to x. And say d by dx, 1, 2 is equal to x plus 1. And d by dx, 2, 1, so that's equal now to x squared. And d by dx, 2, 2, that's equal now to say x squared plus x. So what we have for this matrix now is that 2 cross 2, we know that x 1, 2 would be x plus 1, and 2, 1 would be x squared, and 2, 2 would be x squared plus 1. And from this now we could find the determinant here, full determinant. And for the determinant of this 2 cross 2 now would be equal now, if we say d as the determinant, would be equal now to x into x squared plus 1 minus x squared into x plus 1. And now this would be equal now to x cubed plus x minus x cubed minus x. X in x cubed plus x minus now x cubed minus x squared. So this will go, and what we'll have now is x minus x squared for this determinant. Let's take another one. We have another 2 cross 2 here. And for the first row, first column, we have know that it's in a differential we have know that d by dx 1, 1, d by dx 1, 2, d by dx 2, 1, and d by dx 2, 2. And the determinant in this differential notation would be now d by dx 1, 1 times now d by dx 2, 2 minus d by dx 2, 1 times d by dx 1, 2. And so now we're going to have some representation of the differential in terms of x and constants. But let's, for this one, just leave it determinant in the differential notation. And so similarly, we could move on now to a 3 by 3. And so for 3 by 3, let's have now d by dx 1, 1 for d by dx 1, 2. That's for the element of the second row, first row, second column, and d by dx 1, 3. And then we have now d by dx, extend this thing, 2, 1, d by dx 2, 2, and d by dx 2, 3. So we're building up a 3 by 3 with the elements being in purely differential parameters. So we have now d by dx 3, 1, d by dx 3, 2, and d by dx 3, 3. So that's it now. We have a 3 cross 3 matrix now, and the elements of the matrix are in differential notation. So we could easily write this now to represent it in a sort of a more. So we have now that d by dx 1, 2 will be now equal to y prime 1, 2. d by dx 1, 2 will be equal to y prime. This is y prime 1, 1, 1, 2, and y prime 1, 3. And as we continue, we are saying now that d by dx 2, 1 will be equal to y prime 2, 1, y prime 2, 1, y prime 2, 2, and y prime 2, 3. For the third row, first column, we have now y prime 3, 1, y prime 3, 2, and y prime 3, 3. This is just simply using our differential notation, usually that dy by dx is equal to y prime. Now if we do the determinant of this 3 cross 3, that would be now equal to, we want to find d. As a separate thing now. This is just a matrix. try to make some space here now. D, the determinant. And since this is easier to write here, we just do use a y prime. The determinant now is equal now to y1. And for you, we have to be know to use the signs of the elements. And so if we start here now as plus, this will be minus, this will be plus, this will be minus, this will be plus, this will be minus, this will be plus, this will be minus, and this will be plus. So see now the determinant will be equal to plus y1. Let's start up here. Y prime into now this 2 by 2 here plus y prime 2 2 minus y prime 2 1 2 3 minus y prime 3 2 and plus y prime 3 3. And this will be, minus now y prime 2 1 groping for space here now into y prime 1 2 we're coming down this column here, so we use now minus y prime 2 1. Notice we could also go in this way, but we have chosen to go this way. Minus y prime 2 1 into now y prime 1 2 y prime 1 3 minus y prime 3 2 and plus y prime 3 3. And for this one, we have now a plus y prime 3 1 into y prime 1 2 y prime 1 3 plus now y prime 1 2 and minus now y prime 2 3. Now we know to find determinant of 2 by 2, so we'll just simply find this determinant here and multiply it by y prime. Similarly, we find this determinant. We have just done a 2 by 2 here extensively by taking crisscross in this and y prime 1 2 times y prime 3 3 minus y prime 3 2 times y prime 1 3. So that's how to find the determinant of a 2 by 2. And so 3 by 3 determinant is broken down into some components of a 2 by 2 determinants. We could continue with this using this element and this element and this element, or this element, and this element. Similarly, getting some 2x2s like that. What we're doing a build up here from an impromptu sort of fashion. I didn't plan this, but we're just using now some differential notation in our 2x2 and 3x3 breakdown of the Amz5x12 matrix. So this will be to be continued here. And so suppose now we pull out just one of them for example, this one. So what we'll have now, we'll have y prime into y prime 2, 2 with the elements this. So let's try to write that down. So let's just transform it to this place here. We'll have no y prime into y prime 2, 2. And the other elements here will be y prime 2, 3. And this will be y prime 3, 2. And this will be y prime 3, 3. Okay, so I've just used this one here to find this, just as the determinant of this now, and we're going to subtract it from this determinant of this, and we're going to add it to the determinant of this. And likewise, we have to continue. We could continue with these elements here in a similar fashion and get some representation into this plus 2x2 metrical representation. And we know to do this part here, so we say that's equal to y prime into now y prime 2, 2 times y prime 3, 3 minus now minus y prime 3, 2 times minus y prime 2, 3. So we're just taking out one of those things and for example, and we simplify it. So this will be a partial component now of the determinant of the 3x3. And for this now, that's equal to y prime times y prime 2, 2 minus now two minuses make a plus. So what we are doing, we are multiplying this and subtract it from this and this. So what you have now is y prime into y prime 2, 2 times y prime 3, 3, which is this now. And we are subtracting it now from the product. Y prime 3, 2 that's y prime into y prime 3, 2 times y prime 2, 3. Minus and minus give you plus. When you multiply two minuses, it gives you plus. So that this would be really a plus here. So that would be equal now to y prime y2, 2 prime y3, 3 prime minus y prime y3, 2 y prime 2, 3. Similarly, we're going to simplify now this one, this 2 by 2 determinant, and we are going to add it to this one, and then we'll be on our way to finding the determinant of a 3 by 3 matrix. So now what we have done, we have broken it down into components, a partial determinant of 2 by 2. This is now a full determinant of a 3 by 3. And we have done, for example now, the determinant of a 2 by 2 from this differential notation. But what we have done is we have transformed the d by dx into a more simple y prime. So that we could isolate, and it will be also help us with our space. So we are on our way now to finding the determinant of this 3 by 3 here, d, of this, by simply breaking it down into components now of 2 by 2 determinants and taking consideration of the signs. So for this now, we'll take a break, and we'll come back with our last communication on the Amz5x12 matrix.